Right, so this is going to be lesson 2. So this is on page 95. We're dealing with letters representing constants. So now, when we find the derivative of an expression, right, containing different letters, like here we have A, we have X, we have B, we have X, we have C, right? We differentiate with respect to the letter that represent the variable, right? So now, the letter that represents the variable is going to be A, right? The variable is going to be X, then A will be considered as a what? As a constant number, right? So this means that other letters are regarded as constants, right? So meaning that letters such as A, B, and C are also regarded as constants, right? And then to know which letter represents the variable, that we have to differentiate with respect to, or look for the letter that makes the place of X in the notation that is being used, right? So now, meaning that with here, let's analyze the given expressions from A to D. So here we have A, we have B, we have C. Then A, B, and C are going to be considered as what? As the constants, right? Then here we have a derivative of V in respect to T. Then we know that here U and A, so U and A are considered as constants. Then here we have a derivative of an expression, meaning that here we have P, we have Q to the power squared, and we have R squared, meaning that P, Q, and R are considered as what? As constants. Then we have a derivative of N in terms of N. So here is going to be F of N. So this is N. Then A and B are going to be considered as what? As constants. Right, now let's solve the following. So now here we have an expression, not an expression, equation. So we have F of X, which is equals to AX squared plus BX plus C, right? So now A is a constant, so it's going to be 2 multiplied by A, which is going to be 2A. Then it's going to be 2 minus 1 is going to be X. Then here we have 1 multiplied by B, which is going to give us B. 1 minus 1 is 0. Any base to the power 0, it's 1. Then here C is our constant value. There's no variable, so it's going to be a 0. Then your final answer is going to be this one. So the derivative of derivative of F in terms of X is going to be 2AX plus B. So this is going to be A. So this is minus 1. This is times 1. Minus, it's 1 minus 1 and 1 times 1, right? Then we have B. So B, we have V is equals to U plus AT. So U is a constant number, so it's going to be 0. Then here we have T. Remember, T, it's going to be our variable, right? So it's going to be 1 minus 1, and it's going to be 1 times 1. So this is going to give us a 0. T0 is going to give us 1. So meaning that for this one, the derivative of V in terms with respect to what? To T is going to be A. Then let's move to C. So with C we have derivative of an expression of Pm to the power 3 minus Q squared M squared plus R squared. So here we know that P, Q, and R are going to be constants. So here it's going to be 3 multiplied by P is going to be 3P. Then 3 minus 1 is going to be squared. Then here we have 2. Remember, it's not going to be 2 multiplied by Q squared. Q is a constant number, so we have to look at the variable. The variable here is going to be M squared. So you're going to use the exponent of M, not of Q, right? So it's going to be 2 multiplied by Q squared. It's going to be negative 2Q squared M then it's going to be 2 minus 1, which is equals to 1. Remember, this is a constant on its own. On its own, we are not going to use its exponent. Then from there, we have r squared. R is our constant number as well. So do not apply rule 1 when you differentiate, saying that there's going to be 2r only. It's just going to be a 0, right? So meaning that here it's going to be 0. Then your final answer is just going to be 3pm squared minus 2q squared m. That is going to be your final answer. Then let's look at D. So with D, we have f of n, then we have square root of a, then we have n to the power 3, then we have minus b square root n, right? Now here we know that square root a is our constant, meaning that the whole of square root a, so there's no need for you to change square root a to be a to the power 1 over 2, right? So meaning that it's going to be 3. We're looking at what? We're looking at the variable of n. So this is going to be 3 multiplied by square root a is going to be 3 square root a. Then here we have 3 minus 1, which is going to give us what? Which is going to give us 2. Then here we know that this is going to be our variable. B is our constant value. So B is going to be, so this can be expressed as n to the power 1 over 2, right? Then we have square root a n squared, then half multiplied by b minus b is going to be negative 1 over 2 b n. Then this is going to be half minus 1 is going to be negative 1 over 2. So this is going to be the derivative of f in terms of n. Remember, this is our constant, this is our constant, this is our constant value. Do not apply rule number 1 to say this is 2r. No, this is our constant. Constant values are equivalent to 0. That's that.